So the reason I picked this problem is there is an identical one on your quiz, which is the one with math. So tomorrow you have a quiz over your notes. So I'll tell you to find something in your notes and you got to go find it. So it's not really one you can study for, but the one on Monday, you remember you have a test next week and a quiz on Monday. A question like this would be on it. So what do you think would be helpful to understand this word problem? What could we do that we don't have?
Find the original.
I heard someone say it. Draw a rectangle. Yeah. Let's draw a rectangle. Actually, we're going to draw 2 rectangles. Because there's the original garden, and then there's the one that they made larger. So our original garden is 6 feet wide by 15 feet. So we've got a width and our length. It doesn't really matter, bless you, which one you label which. What matters is in our new rectangle, we're going to have a length of 35 feet. So 35 needs to be in the same spot as which of these numbers? 15. So if you were doing this on your own and your rectangle looked a little different, the thing that mattered...
Would the 6 have to be up and down since it's the width?
I'm saying if you made if your rectangle didn't even look like mine. All right, find the perimeter of the original garden and of the enlarged garden. So there are actually 3 ways to do this problem. I'm going to do it one way. So first off, there's only one way to find a perimeter, right? We need to add up all the sides. What do we know about the opposite sides in a rectangle? They're congruent. So the opposite side is 6, which means this bottom side is also 15. So the perimeter, you add them all up. 15 and 15 make 30. 6 and 6 make 12. 12 plus 30 is 42. I think it's feet. Yeah, feet. So that's part of our answer. We found the perimeter of one of our shapes. To find the perimeter of the second, you can do 3 different things. I'm going to practice the formula with us. The side 1 over side 2 equals the perimeter of the first over the perimeter of the second. There's a couple ways to solve it, but this is the way we're going to do it today. What 2 sides are we going to use? 15 and 35. Remember that the sides have to be corresponding. So 15 and 35. Do we know the perimeter of the first? Yes, we do. What is it? 42. Do we know the perimeter of the second? No, that's what we're trying to do. I don't think we talked about it yesterday, but you can always reduce up and down if you would like to. You need to know yourself best. If you're not good at reducing, then don't reduce. You're going to get the same answer. If you're good at reducing, it'll make your numbers smaller to multiply. What would we like to do? Sure. Okay. What are both 15 and 35 divisible by? 5. How many times does 5 go into 15? 3 times. How many times does 5 go into 35? 7. So even if you didn't reduce, you get the same answer. You just have bigger numbers to multiply. So we're going to do 3 cross multiply. 3 times the perimeter. And then 7 times 42. Which is what? 294. Divide by 3. Perimeter is 98 feet. Does anybody know the other way we could have done this? There's 2 other ways. What do you think?
Finding the corresponding side that goes to 6.
Mm-hmm. Yeah. So he's saying if you found the width over here, so we could call this x, you could find it using a proportion. You know the sides are proportional. So you could say x over, what would be on the bottom? 6. And then what would my second fraction? If I did x over 6, then my next fraction would be 35 over 15. So remember that the top have to be the same and the bottom have to be the same. This would help you find the length, and then you could just add. Okay, so you get the same answer. All right, so at this point, all right, so we're going to do 8.2. So you want to find in your notes 8.2, not 8.3. You want a highlighter out. I'm going to tell you what to highlight. Keep in mind that I'm the one that made your quiz for tomorrow, so I'm very helpful with these things. So we're going to talk about proving triangle similarity. So 8.2 is solely about what shape? Triangles. So we're going to talk about it. You're going to write this in the big blank. It says similar figures blank. So similar figures have the same what? What are the same? I know what you're thinking of, but that's not what I'm looking for. Not the same size. The same. Oh my lord. Same shape. Same shape, but different size. Sorry, but not necessarily the same size. So same shape, but not necessarily the same size. You need to stop talking. Same shape, not necessarily same size. What Amy was saying, they have blank angles. They have congruent angles and blank sides. Proportional sides. What would we do without you, Amy? So they have congruent angles and proportional sides. What? If you want to be able to find it. It's up to you. However you like to look at your notes. I can guarantee it asks about similar figures. All right, and then what is this signal? What is this squiggle? Tell me. Similar? All right, so if you look at the bottom, I have two stars. The only purpose is they're the same shape, but not necessarily the same size. They are similar to each other. Okay? So we're going to talk about triangles. This is called angle similarity theorem. So I'm going to highlight. If two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So what shape does this apply to? A triangle. Does it apply to a rectangle? No, it applies to a triangle. Okay? So what we're going to do, example 1, determine whether the triangles are similar. So in order for them to be similar, we need two congruent angles. In our first triangle, we have 26 and 90, and 90 and 64. Do we have all the information we need to decide if two angles are congruent?
Yes.
We don't. What could I know, or what do I need to know to come to a conclusion? We need to know angle E. We need to know angle K. So how can I find angle E? Add them. So 90 plus 26, which makes 116. All right, and then take 180. Subtract 116, and that makes not one. It's just 64. 64. It's okay. All right, so think about this. If my first triangle was 26, 90, and 64, I have 64, 90. What do you think angle K will be? 26. So, do we think that these two triangles are similar? Yes. So it says if they are, we're going to answer the question. If they are, write a similarity statement. So a similarity statement, we're going to name the first triangle. So pick a name, any name. Triangle CDE. So whatever we name the first triangle, the second triangle will match it. So we said C first, which is 26 degrees. So what letter will we say first in the second triangle? K. Then we said D, so G, and then H. Don't circle it, we're not done. It said, if they are, write a similarity statement. Then it said, explain your reasoning. Well, why did we decide that they were similar? They have the same angle, so we're gonna list them. So angle C, sure, is congruent to angle K. All right, so we got those angles. What else? Angle D is congruent to angle G. And then last, angle E is congruent to angle H. Okay, so our reasoning is that we had two angles that were congruent to two angles. So technically you only needed two sets. We wrote all three because we're consistent like that. You can go ahead and flip to the next page. Show that the two triangles are similar. Okay, so where are my two triangles? It looks like I just have one.
Inside of each other.
Yeah, so there's the outer one and then there's this teeny tiny one. So if you prefer, you can always split them up. So if you like to look at it this way instead, you do you. I like to look at the original, but it's solely up to you. So right off the bat, we see we have two angles, right, that are congruent to each other. So what we're going to do is we're going to state that they're congruent. We already know that these are similar, so that means two of the angles are going to be congruent. So we have this angle. Can I name it angle B? I cannot. Why can I not name it angle B? Yeah, there's two angles at B. There's the 52 degrees and then there's this one. So I can't name it with one letter. So what is the other option if I can't name it with one letter?
With 2 letters.
Nope.
All the letters.
With 3 letters. So we would say A, B, E. So when you name an angle with 3 letters, you name it like you're drawing it. So A, B, E. Okay. It is congruent. So this angle down here, I'll do it in a different color. How many angles are at this 52 degrees? Just the one. So you can say angle C. Or if you just don't know when to do it, you can always name it with 3 letters. So what would we name this angle if we named it with 3 letters? ACD. So either one is correct. Okay. All right, so that's one set of angles that are congruent in our triangle. Can anybody guess where the second angle that they have congruent?
Meeting line.
Yeah, where they meet, right? They both meet at A, right? So A is congruent to angle A. So because they both share that angle, it's congruent to itself. Okay? So this was like when I said I share this wall with Miss Dix. My side of the wall is congruent to her side of the wall because it's the same wall. Make sense? So because they both have angle A, it's congruent to itself. All right? So that's the answer. Is there any information about E or about D? Nah. This is just what they gave us. Letter B, this one is as difficult as you would ever see. So one thing that we notice, we can start off the bat. You're an educated geometry student, 2nd semester. What angle is not marked, but we know is congruent? So angle V. What kind of angles are V? They're called what? Vertical angles. So they are congruent. We're not making up this information. So I'm going to name the angle on the left first. I can't name an angle V because there's 1, 2, 3, 4 angles at V. So I want to name this angle in particular. So what would I name it, Renee? Sure. He said RVS. Same thing as SVR. All right, and Bryce, you're going to name the other angle. So the one in orange. So when you say VUT, you're naming this angle.
TVU.
Sure, yeah, that's good. TVU. Perfect. All right, so then you're like, where are the others? Do you see these little triangles? What does that mean? You have parallel lines. So I would write this as a note down here. Parallel lines, the first thing that you should think of is a transversal. and I'll explain what I'm talking about. So whenever you see parallel lines, think of a transversal. You have two lines that run side by side parallel, and then you have a line that cuts through those two parallel lines. What do we call a line that cuts through two parallel lines? A transversal. So this is from chapter 3, if you don't remember the relationships. So you have corresponding, alternate interior, alternate exterior, consecutive interior, all that jazz. So what angle is made by these two? What do we call these? They're alternating interior. So alternate interior angles are congruent. So we're going to name these two angles. How many angles are at R? Just one. So I could say angle R. How many angles are at T? Just the one. We're not done. Because isn't there another line that touches both parallel lines? Isn't there this one too? Y'all see it? So what other angles are congruent? Angle S is also congruent to angle U. So these would be your reasoning. Okay? I would write off to the side. Why did we mark RVS? So RVS is this one. So why did we mark this angle congruent to this one? What relationship did they have? They were vertical. So I'm going to write off to the side. Those were vertical. This is not a part of the answer. This is just so you can, if you were comparing to your notes, why in the world did we mark these congruent? And then what did we say was the reason these were congruent? They were alternate interior. So interior because they're inside of the parallel lines. All right, now we're going to go to 8.3. So page 1 of 8.3. So you're going to notice page 1 is on the back. Hopefully you notice we're starting with example 1. Did everyone find example 1? It's just hole punch draw. I don't hole punch them, so it is what it is. Are we all on the same page? Example 1? Hopefully. All right, so we're talking about the sides. This is not on your paper because this is not new information. If the corresponding side lengths of two triangles are proportional, then the triangles are similar. That's not new information. That applies to all of them. So here's what you're going to be doing. In order, well, let's first read the problem. Is either triangle DEF or triangle GHJ similar to ABC? So when they're similar, you'll be using the same scale factor. So what we're looking for, so I would write it up here. We're looking for the scale factor. So what are we comparing to? Triangle ABC. So everything gets compared to this triangle. We're trying to see which one of these triangles is similar to ABC. Only one of them is similar. What word in this problem tells me only one of them is?
Or.
The word or. Either or. Okay? So, what we're going to do, pick a side off of ABC. AC, sure. Okay, so AC, we're going to test DEF first. So we're going to see if DEF is similar to ABC. That's our first thing. Okay? What side corresponds with AC on DEF? DF. So if you see me, I'm putting dots up here because, again, the order of the letters matters. So AC corresponds with DF. Okay? So to find the scale factor, I'm going to find the scale factor from triangle ABC to DEF. So that means 16 times the scale factor, which we don't know. So we call it X. Okay, SF means scale factor. I'll write it out. So 16 times the scale factor gives me what side length on triangle DEF? 12. So divide by 16. What is my scale factor from triangle ABC to DEF? 3/4. So what we want to do is check all of the sides on triangle ABC. We want to see if all of them have a scale factor of 3/4. If they do, then these two triangles are similar. If they do not, then they are not similar. So pick another side off of triangle ABC. AB. Okay, which is 8 times the scale factor. What does AB correspond to on the other figure? DE. So 8 times the scale factor will give me a length of 6. Okay, divide by 8. What is the scale factor for these two sides? 3/4. We'll do the last set, which obviously would be 12. 12 times the scale factor will give me 9. Divide by 12. X equals 3/4. So do they have the same scale factor? Okay, so what we're going to do is we're going to say triangle ABC is similar to triangle DEF. Okay? So, couple things. So like we said, or, here's why we stop here. We don't try the other triangle. It was either or. It was either similar to DEF or to HJ, whatever this is, GHJ. Does that make sense? So because it's similar to DEF, we can stop. It's not going to be similar to HGJ. Does that make sense? Are you good with that? You zoned out as well. Okay. Other thing to take into account, where did I get these first numbers from? Triangle ABC, the first triangle. Okay? So you have to make sure you're doing the same direction. Because if you end up flipping one of them, like if I said 9 times something gives me 12, you would find the wrong scale factor, like this flipped version. Okay? All right, so we're going to do the bottom. Oh, nope, go back. Here we are. It says in exercises 1 and 2, determine whether triangle RST is similar to triangle ABC. So we're doing something very similar, same thing. We just have one picture and 2 separate problems. So in one problem, we're going to figure out if this triangle is similar to this triangle. Then we clear our minds. We're going to decide if this triangle is similar to this triangle. That makes sense? So one at a time, we're figuring out if these are similar. We're doing the same exact thing we just did. So pick a side. We're going to find the scale factor from this triangle to that one.
TS.
So he says TS, which is 7, times the scale factor. Okay, so TS. If you struggle with figuring out what's similar to what, always look at the letters. What is TS going to be similar to on the other triangle? CB, which is 5. So 7 times the scale factor will give me a length of 5. Divide by 7. It doesn't reduce, so it's just 5/7. All right, pick another side from our first triangle. TR, which is 4. So TR will correspond with CA, which is 2.5. Divide by 4. What is the scale factor? What is it?
1.5 over 2.
It cannot be 12.5 over 2.
1.5 over 2.
1.5 over 2? Yes. No. It'd be 1.75 if anything. What?
I got
0.625. So check it. Sometimes fractions do equal to decimals. What is 5/7 as a decimal? 0.714. So do these have the same scale factor? They do not. So these are not similar. So we're just going to say not similar. All right, so we do the same thing. I'm going to compare triangle ABC, because left to right is easy, because that's how we read is left to right, if that makes sense. So pick a side off of my first triangle.
CB.
So ignore this one. He said CB. So CB, which is 5, right? 5 times the scale factor will give me what side length? 2, right? ST is 2. Divide by 5, and x will equal 2/5. That's our first. Okay, so pick another side off of my triangle. AB which is 6 times the scale factor. So what is AB going to be corresponding with? Yeah, 12 over 5. This is not going to be pretty, and it is okay. So type in 12 over 5 first. So 12 divided by 5. 2.4. Now divide it by 6. 0.4. So at first it looks like they don't match, but aren't fractions the same thing as decimals? Figure out what 2/5 is as a decimal. It's the same as 0.4. So right now we have 2 of them that are matching. We just need to confirm that the last side lengths match. So we're going to do 2.5 times the scale factor will give me what side length? 1. So divide by 2.5. And x equals 0.4. So are these similar? They are. So what you're going to do, I'm going to write it right here. It's going to be pretty small. Triangle ABC is similar to triangle, what is it? RST. Okay, we have one more to do together, and then we'll stop for the day. This one is new, but not new. This next problem. Find the value of x that makes triangle ABC similar to DEF. So I even saw my honor students try to do this. What does BC correspond with on the other triangle? EF, right? Some people try to set them equal. Do they look like they equal? They do not. They're not the same length. They are, however, proportional because the triangles are similar. So if they're proportional, what can we do to solve for x? Make a proportion. So I'm going to say x minus 1 over 18. Can you guess why I picked x minus 1 and not 3 times x plus 1? Because it's less work, yeah. It's pretty easier. So we're going to say x minus 1 over 18 will equal, pick another side off of triangle ABC. Try to pick an easy one. AB, why is AB the easy one to pick? And that's not why.
It can be reduced.
What is it? Because the one it corresponds with is a number and not a letter. If you had picked 8, you would have this on the bottom, and then you'd have a hot mess. So this is the way I'd leave it, like this. Now you have one fraction set equal to another. We're going to distribute. 18 times 4 is 72. When I multiply 12 times x minus 1, what do I need to make sure that I do? Distribute. So we'll have 72 equals 12x minus 12. Add 12. 84 equals 12x. So what does x equal? 7. So we're going to pick back up on that tomorrow, the last one, just as a review of today.